right, everyone, I want you to get with me. We're going to be on page 299. Now remember, you are writing down everything that I am writing down. Once this video is finished, you will actually show this to the sub. She will make sure that this looks like what I have written down, okay? So make sure you're writing everything down, okay? So number 1 says to use the rectangles to find the factor pairs for 6. So if you look, we have a 6 times 1, or we could do a 2 times 3. So your factors are 1 and 6 and 2 and 3. Now, anytime if I'm going faster than you can write, remember you can click the pause on your screen and stop it and write that down and continue to push play, okay? All right.
Pardon the interruption, but I need my third grade outstanding students to report to the online.
Then, now draw rectangles to find the factors for factor pairs for 12. Well, we know that 1 and 12 is a factor pair. So 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. So that's a 12 by 1. Then we're going to do a 2 by 6. 1, 2, and then we're going to go 6 over. 1, 2, 3, 4, 5, 6. That's a 2 by 6. And then we're going to do a 3 by 4. 1, 2, 3, 1, 2, 3, 4. So that's going to be a 3 and a 4. So that's our factor pairs here. We've got 1 and 12, 2 and 6, and 3 and 4. Okay. Now, we don't have to draw areas for these. We're just going to list the factors. We know 17 is a prime number, so the only factors for 17 are 1 and 17. Now, 10, we have 4 numbers. 1 and 10, 2 and 5. Same way for 21. We have 4 numbers, 1 and 21, and you guessed it, 3 and 7. Okay. 20, now we have 3. We've got 1 and 20, 2 and 10. Can you guess the third pair? 4 and 5. So 3 sets there. 36, there are 5 sets. We've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Now 50, you would think that there's a lot for 50, but there's only 3 sets. We have 1 and 50, 2 and 25, and can you guess the third one? 5 and 10. We're doing the same exact thing down here, finding the factor pairs for the numbers. 3 sets for 16. Can you guess them? 1 and 16, 2 and 8, 4 and 4. 25 there, or number 10, excuse me, 24, we have 4 sets. And I know most of you all can probably identify, if not 2, but 3, and most of you should be able to do all 4 sets. So we should always start with 1 and 24. 2 and 12, 3 and 8, and 4 and 6. So that's all the factor pairs for 24. Now for 56, we've also got 4 sets. We've got 1 and 56, 2 and 28, 4 and 14, and 7 and 8. So 4 sets there. 4 sets. we're going on over to page 300. And our first number is 25. We're going to find the factors of 25. So first of all, we're going to have 1 and 25. And then 5 times 5. Now 60. You will not believe how many are in 60. We have a huge amount in 60. So let's start. We're going to start our list way up here so we have plenty of room. We're going to have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. I know, it just keeps going on and on, doesn't it? All right. That's how many is in 60. That's a lot for 60. 72 looks about the same. Why do you think that they have so many factors? We'll talk about that when I get back. We've got 1 and 72. 2 and 36. 3 and 24. 4 and 18. 5 and 12. 6. Don't say it. I know what y'all are thinking. Wait, I did that one wrong. We've got 4 and 18. Then we've got 5. That's actually not right. Can you see what I've done wrong there? Because we shouldn't have a 5 for 72. So that should be a 6 and 12. I actually corrected the teacher's book just then. Because if you look, they put that 5 was a factor there. So this is the first time I've used this 4th grade book. So, all right, 6 and 12, 9, and 8. We could turn it backwards around. Look how many's there. We had a lot for 72. A lot. Now, which numbers have 3 as a factor? Meaning, which numbers here can be divided by 3? Can 56? No. Can 21? Yes, by 7. Can 36? Yes, by 3. That would be 12. 48. 16 times, yes. 93. 31 times. What about 71? Nope. It will not go. It will not go. All right. Is 54 a multiple of 3? Yes. If you remember, we can add these two up. 5 plus 4 is equal to 9, and it is divisible by 3. What about number 17? Is 45 a multiple of 7? Nope, because it does not end in a 0 or a 5. Okay, it has a remainder. Is 2 a factor of 97? Well, you can look right here. In the ones place, it's not an even number, so that would be no. 5 a factor of 60? Yes, it is, because as long as it ends in a 0 or a 5, it works. All right, tell whether 20 is a multiple or a factor of the number. Right, multiple, factor, or both. Okay. 60, is 20 a multiple or a factor? It's actually going to be a factor. What about 4? It's a multiple. What about 20? It's both. All right. Name 2 numbers that are each a multiple of 5 and 2. What do you notice about the 2 multiples? Well, I can tell you that 10 and 20 have multiples of 5 and 2. And 20 is a multiple of 10, correct? All right, a quotient is a multiple of 5. The dividend is a multiple of 4. The divisor is a factor of 8. Write one possible equation for this problem. Well, could we not say 40 divided by 8 equals what? Think about it, think about it. You got it, 5. All right, we're going to tell whether these numbers are prime or composite. Remember, to be a prime number, it can only divide by 1 in itself, okay? So, number 25 is prime. What about number 2? It has more than one factor, so it's going to be what? Composite. It has 1, 5, and 25. Got 51. It's composite. I know everybody was going to say, no, this is prime. But what about 3 times 17? Yeah, you got that one. Tricked you on that one. What about number 28? It's composite. 1, 3, 7, and 21. What about 50? You got it. It's composite. 1, 2, 5, 10, 25, 50. What about 83? You got it. It's prime. All right, a prime number of students have which type of fingerprint? A prime number of students. So loop, each of these stands for 2 students. So 2, 4, 6, 8. A half would be 1. That's 9. Arch would have 2, 4, 6, 8, 10, 12. Whirl has 2, 4, 6, 7. Which one is actually prime? Whirl. Only 1 and 7 is divisible by that number. All right, write the first 6 numbers in the pattern. Then describe another feature of the pattern. The rule is we're going to subtract 11. We're going to start with the first number, 99. The next number is going to be 88. Do you know the next number? Yep, 77, 66, 55, 44. Look at multiples of 5. First number is 10. So we're going to, 10 times 5 is 50. 50 times 5 is 250. 250 times 5 is 1,250. 1,250 times 5 is 6,250. 6,250 times 5 is 31,250. Big old numbers. Here's the rule, add 8. The first number is 15. So 15 plus 8, 23. 23 plus 8, 31. 31 plus 8, 39. 39 plus 8, 47. 47 plus 8, 55. This one's divide 4, and your first number is 4,096. So we're going to have 4,096 divided by 4. And I know some of y'all could do this. 1,024 divided by 4 again. 256. Oops. Divided by 4, 64. Divided by 4, 16. Divided by 4, 4. All right, last page here. Says, use the rule to generate a pattern of 4 numbers. The rule, divide by 2. So we can start with 16. Divide by 2 is 8. Divide by 2 is 4. Divide by 2 is 2. So you're just coming up with one to make a rule. The rule is add 3. Look, 3, 6, 9, 12. Multiply by 10, look, 10, 100, 1,000, 10,000. Subtract 6, we could start with 20. Subtract 6, 14. Subtract 6, 8. Subtract 6, 2. I love these pattern ones. It says to extend the pattern of shapes by repeating the rule. Trapezoid circle. What is the 57th shape? Well, first of all, trap, circle, trap, circle, trap, circle, trap, circle. We know that for the evens, they're going to be circles. For the odds, they're going to be trapezoids. 57, is it even or is it odd? It is odd, so it's going to be a trapezoid. So 57 is going to be a trapezoid. This one's a hard one, but I want you to think about it. It's really cool. We're going to go top, over, down, over. So that means this one's going to go back to the top. So this one's going to have a circle here. The next one, we're moving it over. The next one, we're moving it down. The next one, we're moving it over. Do you see what I'm doing? Making it like counterclockwise. So it's going to be here, here. So what's the 102nd? Well, if you do it this way, this is 1. Odd is either going to be top or right corner. See the top or right corner. Now the even's going to either be at the top or the bottom corner on the opposite side. So this is 102. So it's going to be in the top right, because look, there's 2. So it's going to be in the top right. Just scrap the pattern.